Hello, everyone. Welcome back. My name is Perey. I'm an independent consultant. I do a lot of research in augmented reality, specifically augmented reality for enterprise and industrial use cases. I started an industry association called the AR for Enterprise Alliance. If you take that home, you can, And the other thing that I'm well known for is standards and interoperability. I believe that to be successful, technologies need to integrate easily with the IT stack, whatever that is, whether that's in a game environment or an enterprise environment. And so that's one of the reasons that I've been very, very active in the Open Geospatial Consortium for about 10 or 12 years, and I co-chair 2 working groups in the context of OGC. So first of all, what is the OGC? It is an international, it's a global organization with over 400, I think 500 members now. It's been around for about 35 years, started in the time of satellites, and big data was, gigabytes of information. Now it's something else. And so it has a long history, and it has some very, very well-established standards. I'm active in exactly 2 working groups I spoke of just a minute ago. One of them is the OGC GeoPose working group, and we focus on creating a data exchange standard for physically, geographically anchored pose. So as you can see on the slide, we call this geographically anchored pose GeoPose, and the GeoPose standard permits rapid and easy exchange between systems, data exchange. I hope you'll take a look at the standard. It is in version 1.0. We're currently working on version 2. You can also go and see some developer resources at the geopose.org website. So I hope you'll take advantage of that. You'll be hearing more about that from one of the speakers today. The other standards group that I'm leading started over 10 years ago in the W3C. We moved the work into the OGC about 6 years ago, reignited it about 2 years ago. These things sometimes take a long time, people say about standardization, but it takes so long. And I say, well, it's really about timing and coming at the right time. So I believe it's the right time for OGC Points of Interest Data Model. You'll be hearing about that more from another of our speakers today. So that's what I wanted to do. I wanted to set the stage for you that the OGC is one of the standards bodies that you should be paying attention to if you are interested in location-based experiences, real-time location-based experiences, of course. And you'll be hearing more about these technologies in specific examples. And I'd like to turn this over now to my colleague Matthhias to continue and give you an example of how POI standard helps you. Thank you.
Yes, so I'm here as a user of standards, and I wanted to show you what our requirements are in this mixed reality space, because we tell stories and UX, XR experiences. Just a quick explanation of what we do. So one is live action games where you have to run in the real world to catch flags, and the other one is to have locative audio tours where you have to walk in physical space and listen to the audio, and it is somehow related to your environment. So normally what we do is we detect in the very beginning a new user's context. We then query databases and access databases in different places and assemble it to an experience. This happens sometimes automatically and sometimes also manual. So here you see an editor where we edit the JSON in this case, and where you see then where all these local audio spots are placed. Now, what does that have to do with standardization? I just show you what the challenges are at the moment. So when we tell stories, the stories are about your environment. So we are interested in places and in popular sites, for example, so that a museum or a church is appearing in the experience. And for that, we have different databases at hand. For example, OpenStreetMaps, where we see where the roads go through, so we can guide the users through the streets. We have to query that, for example, with Overpass. And then we get nodes and ways and relations, and that's completely its own structure. And then we have like labels, how that's named, so we have geonames, or we have also microformats to figure out when places are open. So if experience says you should visit the backyard of a place, and that's only open during lunchtime, then you cannot experience it outside of this opening hours, so we have to actually look at those. And for map-based stuff also, what we need to know is like where rivers are, or bridges, so that we have real-world obstacles that we know and then can design around it. Yes. Also, other things are like real-time information, like weather data, or like where places are related to each other, like a chain, for example. And there are also other sources. There's like a Open Weather, which gives this back in this, which works with latitude and longitude. There's MediaWiki, where we get also queries, what's around you. Nearby, there we get like everything oriented by the pages. And then there's Foursquare Place Search for commercial places. And we have to put that together, everything. And that in real time most of the time. So you can imagine that you are this person here, you walk around, it takes everything at the same time, place. So we have to figure out where you're looking at, where you arriving, and what time of the day, for example, is. And then we have to parameterize queries in order to create the content. We also cache the stuff, because most of the time these databases are not so fast. And if you're the first time user appearing, arriving at the place, we have a cache miss, and then we have to actually source that data. And so that is already like what we need. So the requirement is pretty clear. It would be nice if everything is standardized and we could just easily parameterize the queries and get standardized data. Now, how that really looks like is, because all the data is also maybe fragmented into different databases because of regions, spatial, right? So one is maybe for Europe, one is for the US, the other one is maybe older and newer, and we have to merge that. We have a lot of fetchers and parsers and API handlers, and then aggregate that somehow with fallback logic and all of that. Yes, they often have like timestamps where you then have to on the fly also detect that. Yes, then there's also other challenges like metadata, like pricing, licensing, like if the status, if it's active or not, local laws which allow to access data or not, and then there's also like the price point. Sometimes there's quotas that you have to meet. Yes, and sometimes you're also not allowed to cache stuff. Yeah, standardization would help so that we have lower processing requirements, so we don't have to research a lot, and it would also help us to code less and to have more robust code, obviously, because we have just reusable components and have visiting patterns. Yes, so that's an example what the POI would do. Here you see the Volksoper in Vienna. And then you can just have, it's extendable, that's kind of cool. So you have these different payload elements where you can just put in new formats and plug them in, and then you have with the visitor pattern and with a factory pattern, you can easily process them. If you want to see our experience in life, you can also visit us at the exhibition later. Thank you very much. Now, Gabo.
Thank you. My name is Gabo Seres, and my day job is I'm a research scientist at Nokia Bell Labs, and my evening hobby is I'm an active member in the Open Cloud Association, and I'm going to talk in the last third part here about how to use GeoPose, OGC GeoPose, for describing the pose of moving cameras in the world. So if you are in this room, then you probably share the same common vision of a real-world metaverse, where we have, like this is an example street in Budapest with all kinds of digital content anchored to the street. And today, this kind of, the accuracy needed for this kind of experiences is only achievable with the visual positioning. We came up with an example protocol, a protocol proposal in this Open Cloud, how to use interoperable visual positioning. But for those who are not familiar with visual positioning, here is an example from one of our partner companies, Augmented City from Italy. So you have usually a traditional 2D or 3D map, which you can use for anchoring. And then behind the visual positioning system, there is usually a point cloud representation, a 3D point cloud representation of the world. This contains not only how different things look in the world, but also some extra metadata. And these point clouds can be geo-aligned with a real map. So if you can localize an image in this point cloud, you can actually localize the camera in the world. And once you have the location of the camera, you can retrieve on the fly. You can retrieve the relevant contents at that area. So as shown here, and show them in an AR session. How typically these systems work, and there are many examples already today. Some of them are open, some of them are not open. This is 10 years ago, a paper was published at ECCV about the general architecture of such a system. On the left side, we see the mobile device runs some kind of self-motion tracking, but only relative motion tracking in a local map that is built on the fly. So there's some kind of SLAM or visual inertial odometry. And this sends periodically keyframes to a localization server, which is somewhere in the cloud, and has this large city model optimized for a long time, basically unlimited processing power. This registers this keyframe with the point cloud map, and because the point cloud is registered with the world, we can describe how the camera is located in the real world. So we can send that back, and with the help of this transformation, we can align the local map of the mobile device with the world. And a typical example for the left side is ARCore and ARcade, and for the right side is Augmented City, Immersal, but also others. And what I'm trying to describe here is this GeoPose protocol, which is an interoperable way of sending these images and other kind of sensor data between these two sides. So the proposal, again, this is a proposal, it's not a standard yet. It consists of a REST API and JSON messages. On the right side, we see an example request from a mobile client. So it has some kind of a request ID, a timestamp, and a list of sensors that are available in this request. In this example, there is one camera sensor, and there is one geolocation sensor. So the camera packs its sensor values, which is an image, also as a base 64 encoded string, and some extra metadata about mirroring, rotation, and image format, whatnot. And the geolocation readings, so the GPS readings and compass readings are optionally added there, but are not necessary. It depends on the service that we're using. So this is a request. Additionally, Wi-Fi, Bluetooth, SSIDs, and so on, gravity vector can be added that can aid the visual localization service. And then the response is simply the same ID, timestamp, and the GeoPose as Christine described. So it's basically a position and an orientation in the world. And there are already many open source implementations out there, so you can take these. I created C++ and Python implementations both for the client side and the server side. And I also created a minimal client and server example. So there is an image with all the metadata, which you can send, and you can have an example server, which does not do the visual positioning. It loads the results from a file and sends it back. So if you are somebody working on visual positioning and you have a service, you can just take our SDK or a few files that you can wrap your service with, and then it can be compatible immediately with all the clients that talk to this protocol. And speaking of which, so there is work in the Metaverse Standards Forum on building such an open source visual positioning system. It is at a prototype stage and is basically based mostly on academic open source projects. But the main idea and main goal is to have something that is working and available for everyone where you can play with. And for today, I brought you an example that I created in the past few weeks or months on connecting robots and smartphones to this open air cloud. So there are several robots and several smartphone cameras in a space moving, and they all run some kind of onboard navigation, so onboard SLAM, and build their local maps. We do localization queries to a visual positioning service, which is a simple one only for this room, and we align everything with the world. And then what we can do, if we convert all the camera poses into GeoPoses, we can actually stream to each other where everyone is in this room, and we can also follow the whole thing on a map view. So this is the proof that everything is happening in geocoordinates. We can open an OpenStreetMap view and see everything live here. The robot can actually leave behind some contents attached to a geolocation, and I can retrieve them when I come there with my smartphone. And probably this is the most interesting part. If you look at the middle, the user clicks in AR, clicks on the floor, and with the raycast, we can actually get the point on the floor, and we can calculate its geolocation and share that and set waypoints for the robot this way. So we can imagine in the future, we might just program our robots by simply clicking on the floor with our fingers, and then the robot would follow that path because it understands in a universal coordinate system what those points are. So that was all from my side, and if you have any questions, we still have a few minutes, so yeah, happy to answer. Thank you.
So thank you very much, Christine, Matthhias, and Gabor. So, question from the audience. If there aren't, I'm actually maybe ask a very layman's one from my side. So we have seen also in the beginning of these sessions that there was this need or let's say goal to port these on the web. So port XR experiences on the web being of different kind. In this case, is this like, does it require an app or it's something that runs on a cloud?
The example I showed, the smartphone app runs in WebXR, so it's just a web application. The robot has a native application built in. On the robot itself. Yes.
So basically, anybody could technically integrate this.
Yes.
On. Okay.
I think you hit the nail on the head that these are technologies that we're talking about that are enabling, and how they are brought to the user experience is up to the developer. So GeoPose endpoints of interest are only ways to bring information more clearly and quickly to whatever platform, native or web, as whatever your choice is. And the more, another thing I want to emphasize on both the GeoPose and the points of interest, to be successful with these specifications, we need to have data sets published using these formats, as well as the ability for tools to query and ingest. So it's a two-way system. If a data set, a data publisher, such as those that for VPS or for points of interest, doesn't support the protocols or the formats, then the developer has to create an interface to translate it. And that costs you time. It's heavy to maintain, and many times it takes a lot of compute resources. So you're either going to run your battery down, or it's going to cost you a lot on, in cloud services.
Please.
One question regarding is this also working indoors, or how do you work with indoor navigation in indoor topics?
So it does not matter where you are. If the localization service supports an indoor map, then it works. So what I showed you is basically a protocol that you can use and swap in your navigation application or the navigation service behind. So if you have a localization service that works indoors, then yes. But it's not on our side.
Okay, I understand. Thank you.
Yeah.
Question here.
Just a quick question. I noticed there was no altitude. Are you not? Is that not under consideration at all?
In GeoPose or in any of them, altitude is an height. Is an option. It's an option in any of the protocols.
Okay, because
it's not a required.
Yeah, I mean, I saw
feature.
The location and the orientation, but not the altitude. And I know it's difficult to calculate also.
It's a question of implementation. What you're seeing are implementations that are altitude neutral, so height neutral. And I think again that it's all based on feature models, and so it's extendable to include any feature that the developer wants to add. And I think it's particularly important, well, it's important in all the use cases, whether you're in a building and you're doing navigation, or for example, in the points of interest use case, if you don't want to send someone too high, but if they're looking up, then there might be relevant information in the sky or in the clouds, so it's all relevant. And I mentioned that the Open Geospatial Consortium started in the area of satellite data and monitoring the world and its atmosphere and all of its features. And certainly that's always been a central important characteristic.
I can add.
Yeah.
In my robot demo, the height of the floor was set to 0. So this is how. So I use the height, but not the geographic height.
Any other question from the audience?
I'd like to ask the audience a question.
Please.
Has anybody ever heard of the Open Geospatial Consortium? Okay, not sure. Thank you. You've heard of them now.
Wait, is that a question or a yes? Please.
I want to just follow up on this altitude. So if you have 0 the ground, do you have a concept in GeoPose that allows me to put this full space with your 0 to a global space? Or something like nested GeoPoses that doesn't have altitude or doesn't make sense,
yes,
but can be nested into something that is GeoPosed in terms of altitude and precise geolocations?
Question to you. I believe yes, but she's the one.
So there are what we call standardization targets. And within GeoPose, there's basic targets, and that's what you've been seeing on the screen. There is a whole series of nested structures. Absolutely, and that's in version 1.0. Conceptually, it's very, very mathematical in order to make adjustments for the curvature of the Earth and many other coordinate reference systems, because it's open to any CRS that you choose. So in the second version, we are simplifying this concept because so many people would like to use it, but find the way it's proposed currently as being quite heavy and complex to calculate. So absolutely, yes. It's both nested spatially and temporally. We have 3 of the profiles. The targets are time-based. So we have, you know, a bracketed time, a limited time, an unlimited time. So you can use GeoPose in and out of these different frameworks, either temporal frameworks or coordinate reference systems. Does that help? Okay.
Maybe
so we have
last
time one last question.
Maybe an element about altitude is also that sometimes it's semantical, so it's floor 1, and then you can put it into a payload with metadata. Maybe like it's.
Hi, is this protocol or well, specifications? Is it already used by any of the bigger players, Google Maps, Surf, or Cesium?
No, unfortunately not. This is very new, and I really hope that they will pick it up and support it, at least as a side project. But yeah, they need to have some kind of interest for it.
Okay, thank you.
I'd like to add that there are, in points of interest standards working group, the biggest contributor is Google Maps as to contribute to the concept so that they are consistent with the way it's implemented internally. You know, that's not a secret that Google has a lot of points of interest in its control. However, they also want to interoperate and help the developers be able to merge their data with maybe proprietary enterprise data or with data from another source of points of interest. There's a lot of public POI data sets that need to be merged. In terms of the GeoPose, there are most of the geospatial tool providers do something internally that's exactly the same concept, and they say that they will implement this data exchange protocol, but it takes a certain amount of customer requests. So please request support for this protocol.
So thank you very much, Christine, Matthhias, Gabor. Thank you.